Hi guys, I am so sorry. I was running a little bit behind here on this one. I apologize. I'm going to try and go ahead. Hey Kay, sorry I'm late. Okay. That's it. There we go. Let it. Okay. Well, it may just be you and me. So, okay. Let me get all my lovely setup here. So, here's what I'm going to do. Okay, can you hear me?
Yes, I can hear you.
Awesome. Okay, so instead of having to do all the chat stuff, you can just ask me questions since it's just you and me for right now. Okay?
Well, I have to say I'm like completely lost and just taking notes.
Okay, well that's fine. Okay, so I'm gonna grab my PowerPoints here real fast. And then we'll get to rocking through this, okay? Like I said, I apologize for being late. We were out running an errand, and I was like, Chris, I gotta get home.
I got a Zoom.
We got a Zoom. I'm like, we're like trying to do everything we can to not get caught by the laws. Okay, so for this is, okay, so it's 5-1. There is the tiniest little thing out of 5-2, and then there's the stuff out of 6-1, okay? So the stuff and the methods that we do out of 6-2 will translate into, like, if there was a 5-2 homework, it could get used over in the 5-2. Like, there's not, the methods that we see in 5-1 could be used in 5-2, but they're kind of challenging to use. So that's where we're going to use the stuff out of 6-1, okay? So what we've got here is we're basically doing systems of equations. And I'm fixing to switch the view so that the video, what mine's recording, is doing the correct thing. So we're doing systems of equations. Now, first thing is we're going to do two variable systems. Okay? What that basically means is we're going to have two equations and we're going to have two variables. The general rule is, and I realize that may be kind of light to read, the general rule is the number of variables that you have, so the number of letters that you have, needs to be the same as the number of equations that you have. So if I'm going to be dealing with x and y, I need to have two equations so that I can figure out the value of x and the value of y, okay? If they only give me one, then it's kind of like just having a regular equation, like y equals 3x plus 5. If I put in an x value, I'm going to get a different y value, okay? When we talk about systems, we're looking for, when we talk about a solution, we're looking for an ordered pair, so an x, y, that when I plug it into both of the equations, it works. It comes out as a true statement, okay? So now, one of the first things that they will ask, okay, before we get into the solving side of stuff for this, okay, is just whether or not something is or is not a solution, okay? So what they're going to do is they're going to give us a system. Okay, so they're going to give us a system, and let me know if you can't see these colors. I'm kind of running around through all sorts of colors right now.
No, it's good.
So what happens here is they're going to use the little braces, okay? And that just says this is our pairing, or this is our grouping of stuff, okay? Now, they'll ask, okay, so they ask, is 4, move my light just a little bit, a solution? Now, all that means is we're going to plug in 4 for X and 4 for Y, and we're checking whether or not that gives us the answer on the other side. Okay, so 2 times 4 is going to be 8 minus 12. I'm still checking whether or not that equals -4. Sure enough, I get -4 equals -4, so it worked in the first one. But in order to be a solution, it's got to work in both. So now I'm going to plug it into the other one. I'm going to do 2 times 4 plus 4, and I'm checking whether or not that equals 4. I mean, 8 plus 4 equals 4. That's 12 equals 4. No. So is this a solution? No. So if they ask for just checking or kind of verifying, quote unquote, whether or not it is a solution, that's all they're asking. It's just plug it in, see if it works. If it does, great, and it's got to work in both. If it doesn't, so like if it had messed up here in this first one, I didn't have to move on to the second one. Okay. So kind of like back when we did like inverses and stuff like that, if we did like the composition F of G, if I didn't get plain X with nothing extra, they weren't inverses, and we stopped our process right there. Okay. So if it doesn't work in the first round, I don't even have to worry about it. Okay. So now, working with this same set, okay, and they can give us lots of stuff to check into the same one. They ask, is 1, 2 a solution? So again, we're going to plug it in. We're going to check and see if this works. So I've got 2 minus 6 equals -4. Again, we're checking on it. So -4 equals -4. So we're good in the first one. And then we're going to check it into the second one. Sorry. 2 times 1 plus 2. Does that equal 4? 2 plus 2 equals 4. That is a solution now. Okay. So if they ask you to determine whether or not something is or isn't, then that's all there is to it. Now, when we talk about instead of them handing me something, okay, so let's say, for example, that this is all they gave me, okay, and they want me to find, generally we're looking for one solution, okay, we're not generally going to have multiple. There are a couple scenarios where that happens, and we'll talk about them in this section. How do I go about, because I don't want to do guess and check. I don't want to try, because we've got every number imaginable. There's nothing that says that these have to have pretty answers, like whole number answers. There's nothing that says they have to be positive or negative or whatever else, okay? Because we can get ones that are like really funky decimals. We can get ones like we saw with this one. 1, 2 worked. It's nice and pretty, but we're not always guaranteed that that's going to happen, okay? So the methods that we're going to look at when all they give me, okay? So we've got 3 methods. And as we go through, we're going to do each one kind of individually. And I'm going to talk about kind of when is each one, like when is it kind of, oh, that's when I should do that. Like this is great. I can use substitution when I see this, or I can see graphing. And it's pretty straightforward when we're looking at selection stuff, okay? So what we're going to do first is we're going to look at graphing, okay? This is probably the one that everybody likes the most, okay? Because it's the most visual. Okay? You can see it, you know it. It's like, oh, okay, well, duh, yeah, that makes sense. Substitution, we've done a little bit with substitution. Think about when we did like quadratic looking stuff where we do the U equals and we'd make it another thing. Kind of that same idea is going to happen in this. Elimination or addition, this is just, it kind of depends on the text as to which one. The idea here is we use addition to eliminate one of the letters, okay? Because the whole point in any of these, after graphing, in these two, these bottom two are the algebraic side of stuff, like I'm manipulating things. The whole idea in either one of these is to get the equations bumped down to one letter so I can get that letter by itself. And then I can say, oh, well, I can solve this and get x is 5. And once I know that x is 5, then I can go back and figure out what my other letter is. Okay, so that's kind of where we're going. So with our graphing stuff, so we're going to start with graphing. Like I said, graphing is the most visual appealing one. Okay, so what we're going to look at is we need to get the equations into y equals mx plus b. They need to be in their graphing format. Okay, then pretty straightforward here, graph them. Okay, you're looking for the intersection. Okay, this is what you're looking for. Now, pros to this, kind of the upswings to this, okay? You're going to easily be able to see the answer, okay? As long as it hits pretty, okay? And by that I mean you're pretty much going to have to be on whole numbers, okay? Because if you're hitting somewhere like in the middle of a grid space, okay, even if you're working on gridded paper, okay, and not like hand-drawn grids, like, ooh, hang on. Oh, okay, my life's going to get easier. I have a two-sided dry erase board.
Nice.
I have grids. So, okay, I was like, oh, this is fixing to get nice, okay? Now, the cons to this is going to be, if it's not on grid lines, so if it's not going to be on like a nice, pretty 7, -2 type of ideal location, if it's going to be on a half marker or a third or a quarter or any of those little like decimal type things, real hard to read, okay? The other con is if the line is not easily graphed, okay? And by that, I mean, we know when we talk about y equals mx plus b, this b back here at the back is where we start the grid space, okay? So like if that's a 3, I go up to 3 on my y-axis, I put a dot. If I've got something like, I've got to start that line at 7/2. So I'm already starting myself off poorly at the bat because I'm going to have to hit, and now, lots of people make him graph pretty well if I'm staying on the halves, okay? But if I'm doing something like 7/4 or, 2/3 or anything where I'm not staying on something that's fairly simple forward to graph, it can become challenging because then not only am I trying to hit kind of here between, okay, at like 3.5, then I've got to try and do, because remember this is rise over run, then I've got to try and go up 3 over 2. I'm still going to have to stay in the middle of the boxes because up 1, even just starting the count of that, is going to put me in the middle of between the next 2 lines, okay? So I'm still not staying on whole lines, okay? So if the answer at the intersection is not on the grid lines, it's a pain in the butt. If the line is not easily graphed, just because of the way it's formatted, probably not my best option, okay? So I'm looking for kind of things that I can prettily graph when we're doing this, okay? So I'm going to flip my lovely board over, okay? And I'm going to put this up here. We are going to do the system x plus 2y equals 2 and x minus 2y equals 6. Okay, so these are going to be the 2 that we're going to do. Now, the first thing is I got to get them into y equals. Okay, so I'm going to pull this up and over here. I'm going to rewrite this. Okay, give myself a little bit of workspace here. Okay, so taking this top one, our x plus 2y equals 2, I'm going to subtract the x over to the other side. And then I'm going to divide everything by 2. So that's going to give me y equals negative 1/2 x. And keep in mind, you are allowed to bring that x down, okay? And then plus 1. Okay. So now looking at this other one, I'm going to start by subtracting the x, same way. So I've got negative 2y equals negative x plus 6. I'm going to divide off that negative 2. I'm going to have to watch my signs on this one. I get y. The negative here is going to make that a positive 1/2 x. And then 6 divided by negative 2 is going to be minus 3. Okay. So now both of these are going to be easy to graph because I've got whole numbers back here on the back. So those are easy starters and those are not real difficult slopes. Okay, so I'm going to slide this down just a little bit. So the first one starts at positive 1. Okay, so it starts at up 1 on the graph. And again, that's because of that 1 back there at the back. And then it was negative 1/2. So I'm going to go down 1 over 2. So from this dot, I'm going to go down 1, right 2, and that's going to give me another dot. Now, the other thing that I do when I am doing gridding, when I'm doing graphing style solving, I know that I only have to have 2 dots. Okay, I only have to have 2. But if I'm going to be looking for an intersection point, and I don't trust myself to draw straight lines over long distances, okay, especially not if I'm not going to take like a ruler to it, okay, I'm going to count that pattern again. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and I'm just going to kind of give myself several dots. Okay, so I'm just doing lots of dots down in that kind of edge. You can also go up 1, back 2, okay? And I'm not saying, like on this, I've got a really large grid space, okay? I may not fill the whole grid, but I'm definitely going to do more than just a couple of dots to get that running, okay? So there's my line for that one. Oops, sorry, I'm going the wrong direction. All right, now, I need to graph this other one. And I'm going to try and pull it. Okay, so this one's going to start at negative 3. So 1, 2, 3. Okay. And then this one's positive. So this is, I'm going to go up 1, right 2. Now, again, when we're doing the graphic stuff, me personally, if stuff is negative, I always put that with my rise. So I'm going down and to the right, or if it's positive, I'm going up and to the right. I like to always move towards the right hand direction. I guess, well, maybe that way. I can't tell. Anyway, so I'm going to go up 1 over 2. Now, again, I want to do more than just 1 dot because the thing here is if I now go from this one and I count another pattern and I go up 1 over 2, I just landed right on top of one of those dots that I'd already graphed. That right there tells me that's my answer. Because both of those lines hit that spot. Even if I went up 1 over 2 again, the whole point of this graphing method is I want to figure out that intersection point right there. And because I did more than just down 1 over 2 and up 1 over 2 and then try and sketch stuff in, because I ran my pattern a couple of extra times, okay, then I'm guaranteed that I know this is in fact my answer, okay? So that is at 1, 2, 3, 4. And negative 1. So our solution for this one is 4, negative 1. Now, you can always check this, okay, by taking 4, negative 1. And I would honestly go back to these over here because that's going to be a little bit simpler than trying to run it into something with a fraction over here. You can always, if you're like, I'm not sure, you can always plug it back in to both equations and make sure that 4, negative 1 actually works in both equations. Okay, so you have that option to do that. So that's graphing. Like I said, visually it's great because I either see it or I don't. Okay, but we've already talked about, there are some limitations to it. as that's processing through. Okay. Blue seems to be showing up the best. Okay, now, next method is substitution, okay? And we've kind of talked about substitutions before, okay? So the idea here is you're going to solve one of the equations for one of the variables. It does not matter whether it is the upper equation or the lower equation. It doesn't matter whether it's x or y. You really look for which one is the easiest thing to get by itself, okay? So personally, I look for stuff like, thinking back to that last one we had, x plus 2y, I would have gotten x by itself. If I wasn't going to graph that, I'm going to get x by itself because it's easy enough. Move the 2y, x is by itself, and I can process forward from that, okay? Then you're going to replace into the other equation, okay? Do not sub it back into the one that you solved for because it's all just going to go away, okay? That's one of the biggest things that I see down there, okay? Then you're going to solve for the variable that's there. Now, the idea here is if I've solved for x, and so it's in terms of y, when I replace the x in the other equation, those are all going to turn into y. So I'm going to have all y's floating around in this equation. So now instead of having 2 letters, I've got 1. And then I can just solve for my letter the way we normally do, okay? Then you're going to, once you have that answer, okay, so you're going to get an answer for that variable, you're going to plug it back into one of the equations to get your other variable. Okay? So like if I know that y is 4, I'm going to plug 4 back in for y, and x is now by itself. It's the only letter, and so now I can solve for whatever x's number is, okay? You don't have to plug it back into both equations. You can plug it into either one of the original starters. So if something looks pretty. Now, pros and cons. Pros. It reduces this down to a 1 variable equation. Okay, so instead of having 2 equations with 2 variables, I'm knocked down to 1 variable. So I just have x or y that I'm dealing with, and I can solve it, okay? One of the cons is when you're doing that, getting one of your letters by itself, you could get fractions, okay? So like we saw when we were doing that graphing one where I needed to divide by 2, I wound up with like 1/2 x. That could happen, and then I'm having to take that equation that has fractions in it and plug it into the other one. So now I've got fractions having to be dealt with in the solving type situation. Now, it doesn't always happen that way, but it could happen that way, okay?
True. I don't have to do Marcy's.
Sorry, I'm tired of erasing things with my fingers.
No, my husband just came home. Perfect timing.
Okay, here we go. All right, so let's look at an example of one of these. So we're going to do 3x plus 2y equals 4 and 2x plus y equals 1. So now, trying to figure out and kind of talking through what I tell myself and my mental process of what I'm doing, okay? When I look at this first one and I see 3s, 2s, and 4s, the first thing I notice, I got 3s and 2s. If I try to solve for either one of these letters, I'm going to have to divide by a number. And seeing that 3 and 2 and 4, besides the 2 and the 4, none of this divides pretty, okay? So I would probably have some lovely fractions that I would then have to deal with, okay? So now looking at the other one, first off, the y is just screaming at me right now. Look, I'm by myself. I don't have a number, okay? Look at me! But even if I was gonna have to deal with fractions, I'd rather deal with like a divide by 2 than I would say like a divide by 3. Okay, to me, because honestly, I could probably go down to decimal if I wanted to with the divide by 2s and have things like 0.5 or 3.5 or anything like that, rather than like dividing by 3. Okay, so but for this one, that y is just screaming at us, get me by myself. So I'm going to subtract the 2x over to the other side, and I'm just going to throw it at the end. Okay, I'm not even going to put like negative 2x up in the front end, just throw it at the back. Okay, it's going to get replaced anyway, it doesn't matter. Okay, so now I'm going to, okay, I don't know if you can tell that this is a different color. It may not look different.
Yeah, it is.
Slightly different. Okay, so what I'm now going to do is up here in this other one, this y, and I'm going to put it in green. It's technically green on my side. Okay,
Yeah.
this I'm now going to replace with that green stuff right there.
Okay.
The concept is, and I'll change this y to green too. If this y is a green y equals this, then this y that's in the other one, I can turn it into a green y and I can replace it with the other stuff. So now I'm going to have 3x plus 2. Now, we do need to use a set of parentheses.
Mm-hmm.
Okay, so all I did is took, if y is this, it's kind of like Chuck E. Cheese tokens. Okay, if a Chuck E. Cheese token, or $1's worth 4 Chuck E. Cheese tokens, and I've got $2, then I've got 2 times 4 Chuck E. Cheese tokens. That's the idea that we're doing here. Okay, so I'm going to move up. So now I've got 3x. I'm going to distribute. That's 2 minus 4x equals 4. I'm just going to combine and clean up this side.
Okay.
Subtract the 2 over to the other side. And then I'll divide by -1. Okay, so divide by -1 on both sides. I get x is -2. Now that I know x is -2, I can take that and I can go back to this equation. I can even go back to this one, okay? And actually, personally, I like going back to the one where I solved, because what that does is I'm plugging everything in on one side, and so I've only got to do math on this side, and it pops the answer for the other letter. If I plug it in up here, like for example, if I plugged it in here, I'm going to have to do 3 times that, then I've got to move that over, and then finish. Even if I was plugging it in here, I've still got to do that multiplication and then push it to the other side. So I'm going to go back into this one. So I've got y equals 1, and then minus 2 times -2. So that's going to be 1 plus 4, and that's going to be 5. Okay, so if we're going to write it in ordered pair, the only thing that I say be cautious about on ordered pairs, now for this one it was okay because we got our x number first and then our y number, is do make sure you're writing in an x-y order, okay? Like, for instance, if you had gotten y first and gotten that it was 5 and then figured out that x was -2, don't write it up as 5, -2. It still has to be x, comma, y in that order, okay? That is one spot that, it's not that students don't realize that it's supposed to be x, y, they do, but they just get into a pattern of, I put the first number I found and then the second number I found. And in some scenarios, those flip-flop from where they're supposed to be, okay? So I just want to make sure that you're, putting them in correctly, okay? So that happens. Okay, now, to describe, to describe this last method, oh, Jesus. When you try to put it on paper, it looks daunting, okay? It is actually the method that most students prefer. If they're gonna do something algebraically, like they can't graph it and they're gonna have to work with the numbers, this is probably the method that they prefer, okay? It's personally, it's my default. It's my default go-to. Okay. It's not that I don't like substitution. I'm fine with it, but elimination or addition just to me moves easier. Okay, than anything else. Okay. So what you're going to do with this elimination / addition version, okay, is you're going to start. Sorry, I got to figure out where my screen is. Okay, so you want variables on one side, number on the other. Okay, so you kind of want it to look the way that they have been handing them to us in the last two examples, with the X's and Y's on one side and that plain number over there on the other side, okay? Now, you need to decide which variable you're going to eliminate, okay? Now, the way that you do this is you look at the numbers in front of those variables, okay? So the concept here is I need to have the same amount of a letter, okay? So like 5x and 5x, or 8y and 8y, but I also need them to be in opposite signs. So I need a 5x and a negative 5x, or a negative 8y and a positive 8y. The concept here is when we do that, I'm going to add the two lines together. And when I take a negative 8y and a positive 8y and I put them together, they cancel each other off. That cancels off. It eliminates out of the system, okay? So things that I look for are, what letter can I make the numbers match up fastest at, okay? So if I have like a plain letter by itself, like an X by itself, I love those because I can multiply that by, if the other one's a 5, great, this is going to go by negative 5. I can automatically create the opposite that I need to have, that opposite amount, opposite sign thing that I need to have. If I don't have that, then I start looking at going through their multiples. Okay, so if I had like the number 3 and 4, I'm thinking, where do 3 and 4 match up at in their going up in their multiplications? And 3 and 4 will match at 12. Okay, so that's kind of the other thing that I look for is, and as we go through, I'll show you what I'm talking about when we're talking about pairings up for that. Okay, now once you have that, okay, you want same amount, opposite sign. Okay, so you're going to do this. Now, to do this, you can multiply one or both lines by stuff. Okay, but it's got to be the entire line. So if I need something to turn into like an 8y and I need to multiply by 4 to make that happen, everything in the line is going to get multiplied by 4 to make that happen. Okay, then you're going to add and then solve for the remaining variable. Okay, because again, once you add the two equations, one letter is going to cancel off. You're going to be left with the other one. Okay, then we're kind of right back with 6x equals whatever. Solve for x. Okay. Take that answer, plug back in, and get other value. Okay, so once you know this answer, kind of like what we saw in the substitution one, we're going to plug that back in and work with that. Okay, now we're going to talk about pros and cons for this. Pros for this is you're not going to deal with fractions. Okay, the only time you might have a fraction is if a fraction was an answer. Okay, like, and that's it. I can keep everything in whole number as far as the coefficients in front of stuff, and I don't have to have the fractiony things. Okay, Another pro is if it looks like, okay, let's say I got, and we're going to do an example where this happens. If you get an answer that is not something that's going to work well to plug back in, okay, so let's say you get an answer like 5/7, okay, or something like that, and to plug 5/7 in is going to be an absolute nightmare, okay, to make that happen. If you made the X's match the first time, go back and redo this whole process and make the Y's match, okay? So you can do it twice if the answers are going to be kind of nick, okay? So cons for this, and there's not a whole lot. You may have to multiply both lines, okay? So there may be like some not extensive multiplication, but there may be some multiplication that like has to happen, okay? Like all the way through, so you've got to do a little bit more multiplying for the setup, but it's not really a big con, okay? To me, this method has less drawbacks and less restrictions than the other two. Like when we talked about the graphing stuff, it's got to come out to a nice, pretty like graphing format, okay? Because if I can't hit that y-intercept pretty, the whole thing kind of falls apart. Substitution, I may get some ugly, stupid fractions I'm having to deal with. Great, and there's not a workaround for that, okay? This, there's not that drawback, okay? I can keep everything. Yeah, I may have to deal with some slightly larger numbers. It's okay. It'll be fine. Okay, so let's look at an example. Actually, we're going to do a couple of examples of these. Okay, so first one that we're going to look at is 5x minus 4y equals 9. X minus 2y equals negative 3. Okay, now the first thing about this one that my brain goes to, and it is not about any means, there is more than one way to go about this problem, okay? But the first thing that I see here is I see this plain X right here. It is super easy. I see 5x up here. I need this to be negative 5x. I'm going to multiply this whole line by negative 5. Sorry. Okay. I'm going to multiply that whole line by negative 5, and I've automatically got my matchup. Okay. So I would have 5x minus 4y equals 9. That's just the first line again. I didn't do anything to it. Distributing this in, I've got negative 5x. Negative 5 times negative 2 is going to be positive 10y. Negative 5 times negative 3 is going to be 15. Okay. Old school elementary school addition. Okay, like column addition. 5x plus negative 5x is going to go away. That's the whole point. Negative 4 plus 10 is going to give me 6y. 9 plus 15 is 24. Finish dividing by 6. I get y is 4. Okay, now I can take this back to any of those equations further up. Okay, now personally, I usually like to stick with stuff that has small amounts. So I'm going to pick this one. So I'm going to do x minus 2 times 4 equals negative 3. So I've got x minus 8 equals negative 3. I'm going to add my 8. And I get x is 5. Now, this is one. If I have to put that thing in ordered pair, it's 5, 4. Don't put 4, 5. It's not the order that I got my answers in. It's still X, Y in my ordering, okay? Because I see that sometimes messed up, okay, when that's processed through. And that's not what I want to have, you know, somebody do, is do all this work and they're fine, and then they accidentally wrote that in the backwards order. Okay, now, let's take a look at another one. So I've got Okay, now this one, I don't have, okay, I don't have the plain letter, so I can't automatically make it match up, okay? So this is what I'm talking about, where I'm gonna look at, and when I do these, I physically process, okay? I think about 4 and 2, where can I make those match up at? And it doesn't necessarily have to be something higher for both, okay? Like I can make 2 match out at 4, okay? Which means I really technically will only have to multiply the second line, okay? If I look at 5 and 3, they're gonna match at 15, okay? And if I'm gonna make them match at 15, then I've got to multiply both lines to make them match, okay? Personally, I always try to make them just match lower, okay? Which means I'm gonna make these match at 4, so I don't have to do anything to this one.
Okay.
Now, that one's positive 4. That means I need the other one to be negative 4. So I'm gonna multiply by negative 2 to make that happen. So again, first line, I didn't do anything with. Distributing along that second line, I'm going to have negative 4x plus 6y equals negative 14. I'm put my addition symbol and go. So again, the x's in this case are going to cancel off. Give me 11y equals negative 11. Divide by 11. Y is negative 1. Sorry, I had to plug the phone in, otherwise it's going to die. Okay, so now plugging this back in, again, I like the smaller numbers in this second one over the top one. So I'm going to do 2x minus 3 times negative 1 is 7. So I've got 2x plus 3 equals 7. Don't worry, I'll move. Subtract the 3. I'm going to have 2x equals 4. Divide by 2. We get x is 2. So again, if I've got to write it in ordered pair, I've got 2, negative 1. Okay. Now, remember how I talked about that we can do the thing twice if we have to? Well, let's look at one of those, okay, so that you understand how and when that would come about, okay? Because honestly, when I did this example early on in my college career, okay, in my teaching career, I was like, oh, let's just plug that number in. Oh, yeah, my life got ugly real fast in a hurry, okay? So first off, now, first thing first that needs to happen is we need to get letters on one side, numbers on the other, because they're all mixed up. So in this upper one, I'm going to subtract the 7y over to the other side. And for this one, I'm going to add the 3x back over to the other side. Now, I am going to go ahead and keep them nice and lined up. Okay, I did go ahead and put like x's under x's and y's under y's, just so that we're seeing it, okay? Now, again, nothing matches right now, and I don't have any plain letters. So, taking a look, 2 and 3, when we go up through their multiples, will match at 6. We agree? Okay. 7 and 5, we're going to have to go up to 35 to make those match, thinking all the way up through that high end. So, personally, I'd rather make stuff match at 6, okay, because it's small. So I'm going to make my stuff match at 6. So to make that happen, I'm going to kind of do both of these at the same time. I'm going to make this one, I'm going to multiply by 3. This one's going to multiply by 2. And one of them's got to pick up the negative for me, because right now the 2 and the 3 that I'm working with here are both positive. So one of them needs to pick up the negative. I'm just going to throw it on the bottom one. Okay, it's your choice. You can pick either one. That's just where I happen to stick it, okay? So I'm going to move these over to here. So now I've got 6x minus 21y equals, and I don't do well with that in my head.
Where's the calculator?
51, and it's going to be a negative 51. Okay. And on the bottom one, I've got negative 6x minus 10y equals negative 34. Okay. And we're going to add. X's are going to cancel. So now I have negative 31y equals negative 85. Divide by negative 31. It don't get no better than 85 over 31. Okay, yeah, I see the faces. Okay, this is what I was talking about. This is about the only time I'm going to deal with the fraction. Okay, number one, I got an ugly fraction as an answer. Fine. Okay, it's no big deal. Now, early on in my math career, like as a teacher, I was like, okay, let's plug this back in for y. And then trying to get everything to a common denominator, and oh my God, it was horrible. Okay, so this is where I was talking about doing that process twice. Okay, so what I'm now going to do is I'm going to slide down. Okay, and I'm going to take that 2x minus 7y equals negative 17. So the same starter equations that we had here. And now we already made the x's match in the first round. So now I'm going to force the y's to match in this to do round 2. Okay, so I'm going to make them match at 35. Now, one of the things that is going to help me out here is I've already got one negative, one positive. So I don't have to worry about creating that opposite sign. They're already in opposites. The only thing I need to do is actually make them match up. So I need the top one to go by 5 to get that up to 35, and I need the bottom one to go by 7. Okay, so pulling this, I've got 10x minus 35y equals, and I'm not going to do that in my head, negative 85. Okay, and then on the bottom one, I've got 21x plus 35y equals 119. Okay, so now we're going to add. So 10 and 21 is going to be 31x. The y's are going to go away. And then 119 plus the negative 85 is going to give me 34. Again, I'll divide by 31. We're going to get x is 34 over 31. Now, one of the things to me that helps me kind of know that, oh, I did my stuff right, is when I look at that solution, they both have 31s as denominators, okay? That kind of, to me, is kind of helpful, okay? Now, if one of them was like, if one of my answers had been 7/8, okay, where it was at 8, and I got the other one was like 3/4, I wouldn't be too off with that, okay? Because I know I could rewrite 3/4 as 6/8, okay, that I correct. But because this denominator is 31, it's not like it's going to reduce, okay? So the fact that I got 31 as denominators in both, that kind of makes me feel like, okay, yeah, I probably did all my stuff the way I was supposed to. And I didn't get like, oh, this one is bottom's 31. This one, the bottom is like 47. And I'm going, oh, crap. What did I do? Okay. Because again, the thought process is, if I took this 85 over 31 and I plugged it back in, everything's going to have a denominator of 31. So it makes sense that getting over 31 as my other denominator thing, logic follows, okay, that it should be like that, okay? So this is, my husband just got home. Okay. He just walked in the door. This is one of the ones where you could do it twice, okay? And again, it's probably a whole lot easier to just run it twice than it is to try and plug an ugly fraction back into the process, okay? And it doesn't take that much longer, Okay, it takes a little bit of space. This is why I said this is the method that most students like to default to, because it is, and like I said, putting it down in instructions, it sounds a lot wordier and a lot more involved than it actually is. Okay, but once you see it done, it kind of makes sense. Now, pictures, and since I have this other side, I'm gonna use it. Okay. Get my print space here. Okay, now, when we're talking about systems, okay, there's actually 3 types. Now, what we've been working with is something that looks like this, and even though that's not on a nice, pretty spot, it's okay, okay? The idea here is there is one solution, okay, and it's going to be at that intersection spot, okay? Now, we've got this intersection spot. That is my solution. Now, this is called consistent. Okay, the system is called a consistent. Consistent just means I get an answer. That's all consistent means, is I get an answer. It's also called an independent system. And that's because the 2 lines can be drawn on their own. They don't need the other one to be able to graph. Okay, so independent just says I have the 2 lines. Now, we can have a system okay, where the 2 lines are actually the exact same line. Okay, and you may be going, well, but I would see y equals 2x plus 7 and y equals 2x plus 7. They're going to do it in those other formats where you don't automatically see that it's the exact same line. So it might be like 2x plus 4y equals this, and they've got like negative 3x minus 6y equals that. I can't see automatically that those are going to come out to be the same line, okay? So you get stuff like this. Now, this one has infinitely many solutions. Okay, the idea here is, and I did them in blue and green, if I pick a dot on the blue line, that dot is also automatically on the green line. And if I pick a dot on the green line, it's automatically on the blue line. So any point that I pick, as long as it's on the line, it is on both lines. Okay, now do not confuse this with all real numbers. Okay, this is not the same. All real numbers says it could be that spot. I still have to pick things that are on that line, okay? I can't pick stuff that's offline. It's still got to be part of on the line stuff. But there, I mean, this line keeps going on forever, and I can just keep picking dots. Now, we are consistent because I can get answers, okay? But these are dependent, okay? And that's because one line automatically graphs the other, okay? I can't see the 2 separate lines because they're the same exact line. So it's called a dependent system, okay? Now, the third type, okay, that we have is when we're running parallel lines, okay? And since we know parallel lines never touch, we know that there's going to be no solution. Okay, since the solution has to be the overlap. Okay, now they won't. Well, no, they'll say this. This is an inconsistent system because remember, consistent means I get an answer. If there's no answer, then I can't be consistent. So we're inconsistent. Now, the other thing is, and they don't sometimes put this on here, these are still technically independent. Okay. Because it's still 2 separated lines that I can see, okay? And so independent says I can see both lines within it, okay? The dependent says I'm getting both of them at the same time. So no solution is inconsistent. Sometimes they'll just ask whether a solution is, they may say something like, the solution is 4, 3. Is it consistent or inconsistent? Well, they told me the answer. It's consistent then, okay? Now, graphically, it's easy enough to see, okay? The question is, what is this going to look like in those algebra methods that we were looking at before? Like how, because I don't want to have to go graph them every time to see if that's what I'm getting, okay? So algebraically, okay, I'm going to show you, I'm going to flip my board over here again. Whee! Okay, we're going to take a look at how do I know when something is, you know, the no solution or the infinitely many is basically what we're looking for, okay? So we're going to look at 5x minus 2y equals 4 and negative 10x plus 4y equals 7. Turn my setup here. Okay, now the other thing is looking at the way this is set up, okay, this is kind of set up nice and pretty for that elimination method. I've already got x's and y's on the same side. Any sort of dividing that I'm going to have to do would create fractions, and I don't want to deal with that, okay? So I also, look, 5 and 10 match at 10. 2 and 4 match at 4. I mean, so it's kind of 6 of one and half dozen of the other, so it doesn't really matter. I'm going to make these match up, okay? So I'm going to multiply this top line by 2 so that I can get, I'm looking for 10x because I want to cancel off with that negative 10x, okay? Okay. We're going to add. So the x's are going to go away because we made a match.
Uh-oh.
What happens with the y's?
They go away too.
They go away too. This is the clue that tells you you're in one of the special ones, okay? If all of the letters go away, okay, that's what tells you you're in either the no solution or the infinitely many. That's the clue. If there's letters left over, you're going to get an answer, okay? So we look at, I have nothing left on this side. When I add on the other side, I get 11. Does 0 equal 11? Nope.
No solution.
Then it's no solution.
Okay.
So if all of your letters go away, that's your hint, okay? If all of my x's and all of my y's cancel each other out when I do the combining, however that is, whether it's substitution or elimination, and when I put them together, they all cancel off to where the only thing I'm left with is just numbers, okay? I am looking for how those numbers interact with each other, okay? So in this case, I've got nothing equals 11. That can't happen. That means I'm in no solution. That says these two lines, if I were to graph them, would have been running parallel to each other. Notice, there's nothing about that that says, same slopes. There's nothing in there that makes me think, oh, that has the same slope as the other one. No, like, there's nothing there for that, okay? So it's not one of those things that I look at and go, those might be parallel. There's not, okay? So now, looking at another one, because I want you to see kind of both versions, okay? Okay, now, this one, just because of the way it's presented, feels really nice for substitution because they've already got x by itself here, okay? Why work harder and have to bring the y's back across and then make them match up and whatever else? Like, why do that if they've already got a letter by itself, okay? So sometimes just the way that they present a problem steers me one direction over another, okay? And again, it's not that you couldn't do this with that elimination way. It just makes a little more sense for me just with the setup for this. So I'm going to replace this x with that chunk. Now we're going to distribute. Now, depending upon how much stuff you're going to do in this next step, okay? If the only thing you do is combine your y's, I've got 20y and minus 20y, they're going to go away. That's going to leave me negative 40 equals negative 40. Wait a minute, all of my letters just went away. That means it's got to be one of those special ones, okay? So, but 40 does equal 40. So if they equal each other, this is your infinitely many. Okay? Now, just so that you're aware, okay? So that everybody's aware of this, okay? If back up here, going back up to this other one that we just did before this, okay? If it had been the infinitely many version, I would have gotten 0 on this side and 0 on that side. So I would have gotten a 0 equals 0 type setup, okay? If this one had been a no solution, I would have gotten these two cross off and then maybe something like 30 equals negative 40. I still would have had two different numbers that would have been going through the process, okay? So again, the idea here is anytime that all the letters disappear, you know it is either going to be a no solution or an infinitely many. You're automatically in one of those two, okay? Now, the only other thing that I will say to be cautious with, okay, is, and this is something that for whatever reason, students like, I don't know, their brains just go, ah! Okay? Okay, let's say that we had something that looked like this. Okay, and I add them up. That goes away. Everybody wants to jump to no solution. No, that's just that y has to be the number 0. Okay, everybody freaks out when 0 pops up into stuff. Okay, there is still a letter here. That means I'm getting an answer. Okay, it just happens to be that y has to be the number 0 in order to make whatever this thing is work. Okay, that's all that means. Okay, so students sometimes will mix up all of the letters disappearing and I know I'm in either no solution or infinitely many and I still have a letter but it's 0. Okay, so like don't be scared off by zeros. Like don't jump to that automatically means it's one of those special cases. Okay, now one of the applications that we see done for this, okay, is what's called break-even analysis. Okay, this is definitely a business or economics type application thing. And so what happens here, we have a revenue function. Okay, generally written R of X. Okay, and the way that we do this is, okay, it's going to be the selling price of the object with an X behind it. Okay, the idea is this is telling me how much money I'm bringing in. So if I'm selling something for $200, my revenue function is 200X. Where if they tell me I sold 15, I know 15 times 200, that gives me my revenue. Okay, now we're also going to have a cost function. This one is oftentimes called C of X. Okay, now this is okay, so cost function, you've got to have your fixed costs. This is your stuff like it may have been research and development, advertising, rent, bills, utilities, things like that. that whether I make one of them or I make 1,000 of them, I still have to pay that out, okay? The cost per, this is the material cost to make that item, okay? So let's talk about if I was making a sweater, okay? I might have something here in my fixed cost where it is the money that I invested in the sewing machines, the money that I put in to pay the electric bill and the rent on my warehouse and all that kind of stuff, that whether I produce one sweater or 100 sweaters, I still have to pay those bills, okay? Now, this over here is the cost in yarn, okay? So if I figured out it takes me 15 yards of yarn to make it, okay, and yarn is $1 a yard, then it costs me $15 to make that sweater, okay? And that's per. And this might include, this could include anything like, you know, if we were doing things like computers, it would be the cost of all the little circuits and all of the little housing things and the monitor or the screen and the, you know, the keyboard, all those little things that if I'm putting it together, even though I'm buying it in bulk, I still know how much it is per part that I'm sticking into this item, okay? So those are my costs for that, okay? Now, break even is when R of X equals C of X. This is when the amount of money that I have spent is the same amount of money that I brought in. So right now, to me, that just means I'm at zero, okay? I have at least made back my investment and my cost, but I'm not making money yet, okay? Now, sometimes they will talk about a profit function. Okay, and profit is revenue minus costs. Okay, so profit is revenue. Think about it, okay? I mean, do this on like Little Susie's making a lemonade stand. Okay, I mean, just think about it on that level. If Susie wants to figure out how much money she made, okay, profit, and you know, mom and dad fronted her $20, okay, to buy the cups and the ice and the lemonade mix and the whatever, you know, the cart, you know, the poster board and the whatever else. They fronted her $20 to do it, okay, and that made it. And she sold it all, and she walked away with $50, okay. First thing she's got to do, she's going to pay the $20 back to her parents, okay. So her profit was the $50 she brought in that was in her little cash box, minus the $20 in costs, and that left her with the 30, okay? Now thinking about that cost function, okay, the fixed cost stuff for the Little Susie's lemonade stand would be things like markers, poster board, okay, stuff like that, okay? The cost per, not that I would want to do this, okay, but I could figure out exactly how much each paper cup cost. Okay, like if I paid $4 for the bag and there were, you know, 40 of them and then they were 10 cents a piece. Okay, so I could say the cup was 10 cents. And then I could figure out, not that I want to, but I could figure out that for a pitcher of lemonade, not including water, okay, like we'll negate the water part of this. But if you're buying the big powdered thing of lemonade and you know that that will make 20 pitchers of lemonade, okay, and the thing costs $5, you can figure out exactly how much it is per pitcher, okay? And then if I know I can get 30 cups in a pitcher, I can then sort, you know, divide it down again and figure out I spent this much on the lemonade in that cup, okay? That's what we're talking about when we're doing the cost per, okay? And again, on little scale stuff like, you know, Susie's lemonade stand, you're probably just going to lump it all together and say, I spent $20 in supplies, okay? But when you get up into bigger scaling stuff, like I'm going to make computers, I'm going to make wheelchairs, I'm going to make shoes, I'm going to make any other kind of product, this type of stuff now becomes research and development, advertisement, where it doesn't matter whether we sell one or we sell a million, that money has still had to come out of our pocket in advance before it. And it is in no way lined up with the materials, the leather, the shoelaces, the, rubber, the whatever else that is physically being used to make that shoe. Okay, so now the one thing I will say is when we work with this profit function down here at the bottom, be careful on that subtraction. Okay, because that cost function has two things, make sure you're putting that cost function like in a set of parentheses if they ask you to find a profit function. Okay, sometimes they don't ask for it, but sometimes they do. Okay, so for example, an example. Okay, so we've got they're making running shoes. We've got fixed costs, and they outright say fixed costs of $300,000. Then they say costs $30 per pair. So this 30 bucks is like the leather, the shoelaces, the rubber, the stuffing, the whatever else, okay? The thread to stitch it together, however you want to do that, okay? They're sold for $80 a pair. Now, the first thing it asks is, what is my cost function? So, from the previous information, I said it is fixed cost, so that's my $300,000 plus the cost per pair, which is 30, and then I put an X on that per pair part. Okay, because I need to know how many shoes I'm producing to know how much that part of it costs. And that's it. That's my cost function. That's done. Then it asks me to do a revenue function. Okay. Well, revenue is just the selling stuff. Okay. So now, the next thing that they ask us to do is break even. Now, for break even, we said the two things have to get set equal to each other. So I'm going to take 300,000 plus 30x, and I'm going to set it equal to 80x. I'm going to subtract my 30x back over to the other side. That's going to give me 50x. And then divide by 50. Gives me 6,000. So what does that mean? Okay, that means if they make and sell 6,000 pairs of shoes, they will have brought in the same amount of money that they spent. Okay, now the reason that we want to know where the break-even spot is, okay, any number of pairs of shoes that are sold after this 6,000, I'm now going to be making money on, because that says I will be bringing in more money than I had to spend. Okay, anything before the 6,000, I'm going to be taking a loss because I have spent more than I'm bringing in. Okay, it kind of makes sense. Even going back to like Susie's lemonade, $20. I mean, she needed to make at least $20 to not take a loss on it. Okay, because if she makes under 20 bucks, she can't pay the entire $20 back to her parents. Okay, if she makes over the $20, then she's starting to bring in a profit. Okay, and she can, again, if we set it all up, we can figure out the number of cups of lemonade she would have to sell, okay, type of thing. Now then, with this one, okay, and it didn't ask for this, but just so that you can see it so that you're not, caught off guard. If they ask you to do a profit function, we said that that is revenue minus cost, okay? And again, because cost has two things in it, you want to put that in a set of parentheses, okay? Because you want to make sure that you're subtracting all of this. And if you didn't have the set of parentheses on there, this only looks like I'm subtracting the 300,000. Looks like I'm adding this, okay? So then you can put that. Now, you can clean this up if you distribute, okay? Okay, and we could clean it up even a little bit more. So 50x minus. Now, the reason that you would want to have a profit function, okay, is if you were having to, or in a scenario where they were going to ask, well, what would the profit be on, what kind of profit are we looking at on 7,000 pairs? What kind of profit are we looking at on 10,000 pairs? What kind of profit are we looking at on 8,500 pairs? Instead of me having to go back in and figure out the cost and the revenue and then subtracting them and having to make it into like this 3-step process of find the revenue, find the cost, subtract them from each other, we now have one equation for it, okay, where I can just plug in 7,000, I can plug in 10,000, I can plug in 8,500, I can plug in any number they want me to, including the ones below the 6,000, okay? And what's going to happen is that profit will come out negative, okay? So if it's a loss on it, it'll say negative $3,000 or something like that. Okay, well, that means we're taking a loss. We haven't hit that break-even location, okay? So that's the end of 5.1, okay? Yeah, I know, 5.1's got a lot in it. Now, 5.2 is super stinking short, okay? Because there is literally one definition that we've got to look at, and then it's kind of a verifying thing, and then we move on into 6.1, okay? And I'll get there. Okay, so for 5.2, okay, we're going to look at three variable systems, okay? Now, thinking about what I said at the beginning of 5.1, if I'm going to work with three variables, logic says I need to have three equations. Okay, so now what we're going to have here is what's called an ordered triple. So instead of an ordered pair, it's an ordered triple. Order for this is, so instead of X and Y, we're going to have X, Y, and Z. Okay, so again, it just goes alphabetically when we're doing this. Okay, now, if you're trying to get a visual of what we're doing, because it's really hard for us to, number one, okay, graphing's going to suck. Okay, there is no good way to put it. Graphing's going to suck because it's got to be 3D graphing now. Okay, you've got to, and what happens now is an equation in 3D now represents like an entire flat plane surface. Okay, so here is, close, it doesn't have clutter crap in front. Okay, so
like a cube.
Do what?
Like a cube.
Kind of, sort of, but send it in. Yeah. So visually, you would be graphing into a 3-dimensional space. So you would have surfaces. Think of like a flat, almost like a sheet of paper. Okay, that extends. Okay, So now, what we're now starting to look for, okay, is, okay, you got a corner close by that you can kind of look at, like just corner in the room?
Yeah.
Okay, so one of these equations represents one entire wall. Like all the way across, all the way up and down. That's one equation, okay? Now, another equation, a second equation, describes another wall, and we are first off going to look at where those two come in and intersect, okay? Now, the problem is that those two intersect on that entire seam from the top all the way down to the bottom. Does that make sense?
Mhm.
Okay, so right now, as long as I can put my finger on a spot where the two walls touch each other, I found an answer. So we're kind of in that infinitely many type thing. Does that make sense? Okay, that's where the third equation comes in. The third equation is the floor.
Okay.
So now you're trying to find that one spot right there in the corner where the two walls and the floor meet up in that one little spot.
I gotcha.
That's the 3D idea, okay? Which is why graphing is not going to be an option, okay? Now, it is not to say that you cannot do substitution. It's just a big pain in the butt, okay? Because what you've got to do is you've got to do that thing twice. You've got to say, solve for x, one of the equations, solve for x. Replace that in both of the other equations, okay? So now both of those are going to have y's and z's. So you're going to have two of them that have y's and z's. Then you've got to take one of these and solve for the letter, okay? So solve for z. That's going to leave me y's, okay? So once I have y, then I have to go back to one of those y, z onlys and solve for z. And then I've got to go back up and solve for x, okay? So it's not that it can't be done. It's just a lot more involved, okay? Same thing with elimination. Now, with the elimination thing, what happens? So here's our three, okay? I would have to take two of my equations and get rid of a letter, okay? So let's say we got rid of z. So I have x's and y's left over. Then I'm going to have to take one of these two original ones, and I've got to partner pair it with this one, okay? And I've got to get rid of the same letter. So I've got to get rid of z's again, okay? So what that's going to leave me is when I partner paired these two, I got one new equation. When I partner paired these two, I got another new equation. So now I've got these two over here that don't have z's in them. They have x's and y's. Now I've got to partner pair these two and get rid of a letter. And then again, I've got to start working backwards, okay? So it takes a lot of keeping track. Yeah. Okay, takes a lot of keeping track of where stuff is, okay? So, and again, it's not that it can't be done, it's just not the prettiest thing in the world. So, what we're going to look at, and it's more so going to be over in the chapter 6 section, okay? It's going to be another method for how to solve that stuff, okay? So, but for this one, okay, still in section 5.2, okay, they can still ask the questions like, so again, we've got three equations, there's three letters. Now, again, with that ordered triple, they go in order, they go alphabetically. So when they're asking, is it a solution, we're doing the same thing we did at the beginning of 5.1. We're just plugging stuff in. So plugging into the first one, I've got -1 minus 2 times -4 plus 3 times 5. And I'm checking, does that equal 22? So -1 minus 8, or sorry, that's plus 8, plus 15, does that equal 22? -1 and 8 makes 7. 7 plus 15 is 22, so it works in the first one. Now, again, this is at any point in time. If it messes up, it's not a solution. So just because it works in the first equation does not mean it's an automatic shoe-in for the rest of them, okay? So I'm going to plug it into the second one. I'm going to see about the second one. So I've got 2 times -1 minus 3 times -4 minus 5, and I'm checking, does that equal 5? So -2 plus 12 minus 5, does that equal 5? -2 plus 12 is going to be 10. 10 minus 5 is 5. So it happened to work in that one. So now, plugging into the last one, I've got 3 times -1 plus -4 minus 5 times 5, and we're checking, does that equal 32? -32. So I've got -3 minus 4 minus 25. Sorry, my brain just went. -3 and -4 is going to be -7. -7 minus 25 is -32. So since all three of them worked, okay, then yes, that is a solution to that problem or to that system. Okay, now I'm going to keep this system, okay, so that I can talk about a couple of vocabulary things that are going to come up in 6.1. Okay, so I'm going to get rid of the upper part of this. Okay, so 6.1. This is matrix solutions, okay? Now, what a matrix solution basically is, it is a blocked way to deal with numbers only to get to answers, okay? Now, the first thing that we've got to talk about is we got to talk about an augmented matrix. Okay, now what this is going to look like is, now this thing is going to be 3 lines of numbers. Okay, so the box here, this edge, is 3 lines of numbers. That's how big it is. Okay, now some people, what they'll do is they'll write all their numbers in first and then they'll just put their boxes around the edges. Okay, now what's going to happen here is we're going to go X, Y, Z in order, and we're just going to need the numbers in front of these. So there is 1X, there's -2Ys, and there's 3 Z's. For that first line that we have up here, I've got 1, -2, 3. We follow so far? Okay. Then I draw a line that is my equals line. Okay, so that I'm separating kind of my letter side from my number side. And then I'm going to put 22 over there on that other side.
Okay.
So then the next line is going to be my next equation. So I've got 2X minus 3Y minus 1Z is 5. Okay. And then my last line will be 3X, 1Y minus 5Z is -32. And then I'm going to close that box H. This is an augmented matrix.
Okay.
Okay. Now, the thing to remember about an augmented matrix is it's always going to stack as the first column is your X's. The second column is my Y's. The third column is my Z's. Again, I draw the line so I can see my equals line so that I know and then I've got my number on the other side. Now, our goal, okay, is I want to make this matrix look like this.
Okay.
And the letters here will be replaced by numbers, okay? But I'm going to explain why we want to do this, okay? If I look at this very, very bottom line, okay, I have no X's, no Y's, and 1 Z. So if I were to come back out of this box into an equation like this, does that make sense? This would be Z equals whatever F is. Because I don't need, there's no X's and no Y's. And there's only 1 Z. So then Z is whatever this number is, okay? Then if I backtrack one line, I would have no X's. I have 1 Y plus, just because I have letters here. And again, the D here would be a number, okay, right? But don't I already know what Z is from the bottom line? Remember, that's going to be a number. It's going to be like 4.
Okay.
So can't I just plug 4 in up here? And then I only have Y with a bunch of numbers and I can solve for Y? And then I know what Z is and I know what Y is. So then we go back to the top line and I'm going to rewrite my equation and I'm going to plug in my Y number, the number for Y that I already know, the number for Z, and then X is the only number that's left over, okay? The question and what we deal with in this section is how do I get from this to this, okay? Now, you may already see some parts that match up. Like I see a 1 right here, and there's a 1 right there. Okay, I'm on a roll. But the question is, how do I get the rest of this stuff? Like, how do I get the rest of these things to be 1s and 0s, okay? And that's what we're going to talk about next, okay? Is what we're allowed to do inside of this to make stuff happen, okay? The other thing is there is a very kind of methodical way to how we go about this, okay? So it's not like a, well, I'm going to do it this way, but I'm going to choose to do it another way. There's a couple little spots where you can make some choices like that, where someone might be a little different, but overall, I have, this is goal number 1, and I'm going to do these steps to get to it. And this is goal number 2, and I'm going to do these steps to get to it. There's not this haphazardness to it, okay? We are not haphazard because of the way that we build stuff. We can't just go, oh, well, I didn't want to do it that way. No, you can't do it that way, okay? Like, there has to be a method to the madness, okay? Now, what you're allowed to do, okay? And this is once you have your matrix, okay? So once you've written that block of numbers, okay? You can switch any 2 rows that you want, okay? So for example, look at, that last one that I just heard at. Remember how we want a 1 in that top corner? Okay, let's pretend that that first line didn't have a 1 in that top corner, but the middle line did. Okay, so it was like 2 and then a 1. I can flip-flop those entire 2 rows so the 1 moves up into that top corner. Okay, so any 2 rows that you want to switch at any time in the process, you can do it. That's allowed. Okay, now you can multiply an entire row by a non-zero number. Okay, now what they don't read into that is you can also divide. Okay, so like if you needed to, you were trying to make something turn into a value and you needed to divide by 2, you're allowed to do that. Okay, now anything that you see in a textbook is going to say something like, you can't divide by 2. You have to multiply by 1/2. It's the same dadgum thing. Okay. And honestly, it just has to do, the reason they say multiply has to do with the way, way, way upper end math stuff. Okay. It has to do with, technically, division is multiplication. So they house it all under that multiplication name. Okay. That's the only difference there. Okay. So you can multiply or divide. Okay. Any row by anything you want to, so long as it's not 0. Okay. Think kind of the same thing that we did when we did that elimination method, where I would multiply all the way through by 5. Okay, same idea. Now, the third thing you can do, and this is very, very similar to that elimination idea that we did back in section 5.1, okay? You can multiply any row or rows, so if you need to do more than one row to do this, you can, and add to replace a row. Okay, so think about, okay, what we did in the elimination. Sometimes we would multiply one line and then add it to the other. Sometimes we had to multiply both lines and then add them together, okay? In both of those scenarios, the idea was to eliminate or get rid of one of the letters, right? Okay, that's how we're going to help create our zeros, is I'm going to be putting like lines together to cancel off to start to create those zeros, okay? So now I'm going to show you just a couple of examples of, one, how they're going to talk about notation so that you know, oh, that's what that means, because sometimes they don't outright say multiply row 2 by 3. They don't say it that way, okay? They use notation for it. And then we're going to do an example, okay? And yeah. This is one of those, this is not a lesson that I would want to try and just read a book and learn. Okay, this is definitely a lesson that you need somebody kind of talking you through your process, okay?
Zooms are great.
So, okay, so here's the matrix that they give you, okay? And they're going to say row 1. I realize that's kind of off, okay? But it's row 1, and then they have this little double arrowed thing, and they say row 2. That means switch rows 1 and 2 in the matrix, okay? Okay, so literally all we did is we took row 2 and we wrote it in the top row spot. We took the top row and we put it in row 2 spot. That's it. That's all that thing asks. So, but notationally, this is what you'll see is row 1, arrow, arrow, row 2. Okay, or row 1 to row 3. Again, it's any 2 rows that you want. Okay, so you're not restricted on that. Now, I'm going to keep this same matrix. Now, this is what I was talking about, okay? 1/4 row 1. I ain't doing 1/4. I'm going to divide everything by 4, okay? Because that's what that means, okay? Now, notice, though, they also kept this thing sitting right up here on row 1. So they're also telling you that that's going to stay on row 1, okay? Generally, we see that note. So 4 divided by 4 is 1. 12 divided by 4 is 3. -20 divided by 4 is -5. 8 divided by 4 is 2. The other 2 lines stay exactly the same. Okay. Okay, so we're cool with that part. Okay, now, that last rule. Now, this is where me and them slightly differ in notationing, okay? Not a lot. I just put something a little more with mine. Okay, I add this back part, okay? So we're gonna do 3 times row 2. We're gonna add that to row 3, and I say I'm gonna put that in row 3's spot, okay? Now, this is the one time I do not try to do this math in my head. No, just don't, okay? Now, so what I'm gonna do is just underneath here, okay? I'm basically gonna kind of just show the math that I'm fixing to do. So 3 times row 2. So I'm gonna do 3 times this row. So that's gonna be 3, 18, -9, and 21. So all I did is 3 times each of my numbers. It says row 3 just by itself. Okay. I'm gonna add this up. And then when I go to write that new matrix, okay? So, like I said, I always put like where this is headed so that I know, okay? Like that's going to now be my new row 3, or that's going to be my new row 2, just so that I have an idea of where am I placing that in this new answer line. Anytime I am doing this type of stuff, I always write it down, okay? This is the one time, especially if I'm having to like 3 of this row with like -5 of that row, I am not going to try and do those numbers in my head and then put them together and make sure that I'm putting things in the right spot. I'm just going to do a quick little write down, and then I'll rewrite the matrix, okay? Cool with that. Okay, now, that's an example of the 3 things that we're allowed to do, okay? So, now, the method to the madness that we're fixing to do, okay? Again, this is one of them lessons. You got to have somebody talking you through it, okay? So, okay, first thing is get a 1 in the top left corner. Okay?
Okay.
So you want to get that first 1, okay? So thinking about, in our matrix, and I'll erase that here. You're trying to get that 1 in that top corner. Doesn't matter what the rest of the stuff looks like. I don't care what's here and in here. I'm working to get that to be a 1 right there in the top corner. Now, how does this done? Usually either you're like switching a row up into it, or you're going to do some sort of like multiply or divide a row by something to make that happen. Okay? You're not generally doing any of the adding stuff at that point in time. Okay? Now, this is where everybody will start to mess this up. Okay? Use row 1 to make zeros below. Now, what I mean by that is, you remember that last example that we just did where it said like 3 of row 2 plus row 3?
Mm-hmm.
Okay? Since you've got that 1 in that top corner, what I need to do is make the number that's right underneath it. So if I've got something like 1 and then a 2 below it, okay? I need to do row 1 times something plus this, okay? So I need to get rid of this 2. So I need to do like 1 times -2 so that I can do -2 plus 2. Does that make sense? Okay. But I've got to use row 1 to make this stuff happen below it. Okay. And then to get rid of whatever this number is down here, like if that's a -5, I'm going to do 5 times row 1 to get rid of row 3. Cool with that? Okay. So now once that happens, next thing is get a 1 in that middle row. Okay. So what's going to happen is after you've done this first part, you're going to have 1, 0, 0 because you'll have made this a 1 and then you get zeros underneath it. Now you're going to make this a 1. That's where you're trying to get, is that next 1 in that middle spot. Okay. Once you have this 1 in the middle, you need to use it to get the 0 to happen below. The reason you've got to do this, if you don't, okay, let me back up. If you do, if I have to do like 3 times row 2 plus row 3, 3 times 0 plus 0 is still going to be 0. So I'm not going to mess up this nice, pretty 0. If I use any other row, I'm going to possibly screw up that 0 that I just made in that bottom thing that I worked so hard for in this first part, okay? But if I only use this row, then I'm getting zeros and zeros in this first part, okay? After you've done that, okay, then you're going to work to get that 1. So now you're going to have, 1 with a 0 under it. Notice, I don't know what the crap is up here in this upper part. Then you're going to get a 1 right here. Okay. Once you know that, you're going to be able to back solve for all your other values. Again, thinking back to when I did the goal matrix, because I've got 1, that's a Z with no other stuff, I know what Z is. Then we're going to backtrack up. This whole back solving will make a little bit more sense as we're working through. Now, here is my suggestion. If you are taking notes and you have got this much space on the bottom of your sheet, turn the page.
I'm good.
Okay? Like, this is not a process that is like short and sweet and simple and to the point. It's just not, okay? So if you've got under, like, seriously, like, just give yourself a new page. Just give yourself a new page, okay? So I'm going to start this up here, and I'm actually going to turn my board sideways so that I can work kind of in columns here. Okay, so here's our matrix. 2x plus y plus 2z equals 18. X minus y plus 2z equals 9. X plus 2y minus z equals 6. Okay? So first thing is we're going to get this into a matrix. Okay, now then, I need to make this a 1 in the top corner. Okay, easiest way for me to do that is just to switch one of these other rows up into that spot. Okay, so I'm going to do row 1 switched with row 2. I'm just going to make those top 2 rows flip-flop. Okay, so now I've got my 1 in the top corner. Now I'm going to use row 1 to help me make zeros below it. Okay, so I'm first going to focus, and I'm going to do them one at a time. Okay, we're not going to try and do this all in one big process. I need to make this 2 go away. Okay, the reason that I like to do this is, what do I have to add to 2 to make 0? -2, yes?
Yeah. Sorry.
Okay.
Yeah.
That's what I multiply with row 1. So I'm going to do -2 row 1 plus row 2, and that's going to be my new row 2. Okay. So now I'm going to do my little math below here. So -2 times that top row is going to be -2, 2, -4, -18. Row 2, I'm not going to do anything with, and then I'm going to add. Okay. So now I've got the 0 here. I need to make my 0 happen in the next row down. Okay. So since it's a positive 1, I just need -1. Okay. So I'm going to do negative row 1 plus row 3. Notice that I'm also always doing the multiplication with row 1, and I'm letting the other one stay put. Okay, so I'm letting R1, in this case row 1, turn into that opposite amount, okay, kind of the same way we saw in elimination, okay, that I've got that letter by itself, okay, and this is going to be my new row 3. So again, I'm going to write this down, my math underneath. So -1, 1, -2, -9, 1, 2, -1, 6. I'm going to add 0, 3, -3, -3. Okay, and then I'm going to move, I've got to move up to the next spot so that I can write this in. Okay, so I got to slide. Here we go. So I've got 1, -1, 2, 9, 0, 3, -2, 0, 0, 3, -3, -3. So that's the matrix that I got after that.
Okay.
Now, notice I've got 1, 0, 0. That's starting to look like 1, 1. Now, next thing I need to do is make this 3 turn into a 1. This is where I'm going to do multiply by any row, okay? So technically I need to do divide by 3. Do we agree? 3 divided by 3 is 1, okay? Now I've got to write it just so that it follows the other notation.
Okay.
I'm going to do 1/3 of row 2. I'm going to divide row 2 by 3, okay? That's all that's going to happen here. Zero, 1, -2/3, and 0. Okay. And you may be looking at that going, ew, there's a, okay. But that's all I'm going to have to really do with that row, okay? Like it's probably going to sit, and outside of needing to use it a little bit to get this next one down, I'm not really going to, it'll be okay.
Okay.
So now, the same way that we did back over here, like when we did, you know, here, you best not touch row 1 right now, okay? You have got to use row 2 to get rid of row 3, okay? So I need to use my +1 to get rid of that 3. I need a -3. So we're going to do -3 row 2 plus So row 3, and that's going to be my new row 3. Now, when I show you this multiplication, it's all going to make, you're going to, oh, I see why you did that way, okay? Enlightenment is fixing to come, okay? So -3 times the second row. That's going to be 0, -3, +2, negative turns positive, the times 3 divided by, 2, and 0, 0, 3, -3, -3. And we're going to add. Okay, now, let me show you why you don't want to have done this another way, okay? Let's say you had thought, oh, wait a minute, let me just use this -1 up here, okay? So let's say that you had done 3 row 1 plus row 3, okay? Let's just say, for example, you had done that. That would have been 3, -3, 6, and 27. Okay, even if you can't see this part here, look what I just jacked up at the front of that row. I already had nice pretty 0 sitting at the front of the row, and now I just jacked that up by getting a 3 now sitting back in the front. Now I got to go back and fix that dadgum thing. Okay, that's why I say you've got to use the row you just made a 1 in. That is the only row you mess with to make stuff below it. So when you turn this into a 1, you have to use that row to make this happen, because that's the only way you're going to get that 0 and 0 together to keep the 0 going in that bottom line, okay? That's where, if you are not following kind of that method idea, like I said, way back up at the beginning, we did row 1 and row 2 and we flipped them. You could have done row 1 and row 3. That's fine. Your matrix, your matrices would have looked a little bit differently. But overall, it was the same. You're doing the same stuff. The process of what I'm going about doing, okay? Now, we're like one step off from being able to finish this, okay? Yep. So now, I made the one below it, okay? I've got a -1 here. I need it to be a +1. Fine. Negative row 3, just so I can switch all my signs. Okay. Now, let's talk about bringing these out of the matrix. Okay. We start with the bottom row. That's no x's, no y's, 1 z. So z equals 3. That's what that bottom line tells me. Okay. So now, if I move up 1 line, that says no x's, y minus 2/3 z equals 0. But wait a minute, I know what z is. Z is 3. I know z is 3, so I just plugged it in and I solved for y. Now we'll go back up, and I'm kind of out of space here, and I'm going to go back to my top line. So x minus y plus 2z equals 9. But wait a minute. I know what z is and I know what y is. I'm just going to plug those in. Okay, negative 2 is going to be plus 4 equals 9. And again, I did a lot of little baby steps in there, okay,
Yeah.
to do that.
Right.
But now I know what x is.
Yeah.
So I've got x and y and z. So if I need to write that in ordered triple, it's x, y, z.
Oh, wow. There. Wow.
Okay.
How many of these are there?
Not a crap. There's not a crap ton of them. Okay? There's not a whole lot of them. Okay. Now, I'm fixing to put another bright light in this. Okay. So give me just a second. Well, actually, I'm going to do a couple of bright lights. Okay.
Awesome.
First off, this whole thing is called Gaussian elimination. Okay. A guy named Gauss came up with it. Okay. Now, there was another mathematician. He came by a little bit later and he said, Gauss, it's amazing. You did good. I can do a little better. This guy came through and said, I can one-up you. Not one-up, it was just an extension of it, okay? The idea behind this one is the same way that we read on the last one, z equals a number, right? Notice what happens in the middle line. There's no x's and no z's, so y equals whatever this is, okay? The top line is x. There's no x, there's no y's and z's, so we have this. So this makes reading an answer really easy, right? X, Y, Z, straight down the line, okay? The problem is that to get to here, you have to add another, so like you still start the same. You get ones and then you do 0, 0, okay? Then you do 1 and you make 0, but you also go up and make a 0. Okay. Then you make a 0 and you make zeros happen above it as well, okay? So it lengthens the process. It's not that any of the steps change, it just makes it longer. Now, this is called Gauss-Jordan, okay? So Jordan was the second guy, and I think he was French, so it's probably Jordan, okay, probably, okay? But his was this. Now, okay, so the bright light is we don't have to do Gauss-Jordan, okay? All we have to do is Gauss, because if I can get to the point where I've got this basic structure of ones and zeros in this bottom corner, I can get Z, I can backtrack and get Y, and I can backtrack and get X, okay? We're not required to go all the way through this Gauss-Jordan thing. Even though it is nice and pretty for reading answers, it's not required, okay? Now then, the other thing that could happen, okay? Now, you can still get no solutions. Okay, now let me explain where the no solutions show up. Normally, no solutions show up on the bottom row. Okay. I'm just going to put a letter. Okay. So if you remember back when we did the elimination stuff and all the letters went away on one side, but we had a number on the other, check out, isn't that what this row says? No X's, no Y's, no Z's. So there's no letters, but you're still telling me that that equals a number. So it's no solution, okay? Now, remember when we were talking about the 3D versions of stuff of this? Okay, there's a couple of different ways this can happen. One is you've got them stacked like floors of a building, okay, that they're all sitting on top of each other, okay? The other way is, think about, you know those little like prisms that do, like, they shoot the little rainbow things? Take the sides of those, but extend them, okay? So you've got 2 of your things go here, 2 of them are here, and then you've got 2 of them here. I can get 2 of them to hit, but I can't get all 3 of them to hit on the same thing. I can get any 2 because I'm on edges, but I can't ever get all 3 of them to line up like we saw in the corner, okay? Now, you can also get the infinitely many. And now, I'm showing them in the bottom row. If this row were to show up anywhere in the process, it's a no solution, okay? Same thing with this infinitely many. Infinitely many is going to show itself up as a 0 row all the way across, okay? Because that's, I have no letters and nothing on the other side. I have 0 equals 0 total, okay? Now, visually what that is, 2 or more of them are the same thing. So if I had the wall, the floor, and the wall again, it's everything along that baseboard. Any point I pick on the baseboard counts as a solution, okay? So that's where we would get infinitely many, because it's anything on that where they come together type of idea, okay? The other thing could be that all 3 of them are stacked on each other, okay? That it's just all 3 of them layered together as one big mass solid. And so, but we don't know, okay? And it doesn't really matter, because as soon as I have 2 of them are the same object, and where it intersects the other one, I mean, unless it was like 1 and then 2 packed together on top, which we don't do, I'm going to have like an entire line that is kind of that in the corner where they're touching each other type of idea, okay? Now, the other thing is these little buggers can get bumped up to like a 4 variable system, okay? If they do 4 variable systems, it's usually that they're going to do W, X, Y, Z in that order, okay? Now, the other thing is you will not be asked to solve a 4 variable system, okay? You will not. They may ask you to do like, do row 1 switched with row 2 on a 4 variable system, or like add row 1 and row 2 together on a 4 variable, but you will not be asked to solve. Now, the method is the same. You start with getting a 1 in the top corner and you make zeros below it, and then you stair step down and you make 1 and you make zeros below it, and you stair step down and you have to make, it's just the process is a little bit longer, but it's still, you start with the 1 in that top corner, you make zeros, and then you stair step 1 spot down, and you make zeros, and you stair step down, and you make zeros, and you stair step down. I have seen, and one of the classes, you know, that math majors do, is they do a class called matrix methods, okay? And this is what we do matrices. And I have seen these pushed up where they're doing like 5 variable, 5 letters, still kind of being processed by hand, just so that the teacher understands. Past that, and usually even once we get up to 4 variable, we're letting a calculator or a computer take over, okay? We're letting it, because it can do all of those computations, okay, quicker and faster than we can do them by hand, okay? So, but that is the end of 6-1, okay? So we're done with 6-1. It's probably going to be sometime early tomorrow, like tomorrow morning. Maybe I'm going to try and have it done by lunchtime, the testing situation, okay? Since pretty much they've said we can come back, but it's going to be the week of finals, okay? Or like that little half week of finals. We're going to have to do testing online. Like, and I've got to make sure, I've got a couple of ideas in mind. I just need to put them down and see which one I like best, okay? And see which one I think is going to be the most fair, okay? Because I need it to be fair in regards to I am being able to assess y'all's understanding of stuff, but at the same time, I need it to be fair as far as a testing environment goes. And what that looks like, whether it is, you know, and part of it's going to be an honor system. You know, it's going to have to be that you are on an honor system, that you're not, you know, going and looking at outside resources, and you're not calling people, and you're not doing stuff like that. That's part of it. But I also want to make sure that I'm not super limiting and try and make it as close to kind of the same environment that we would have in class. So kind of, I still want to have kind of that idea of a 2-hour-ish window type of thing, okay? If I can. I mean, I may not be able to do that. I may just have to say, look, here it is, take it, I need it back type of thing. If I can get it in, you know, an environment where that doesn't happen, you know, I'll let everybody know. But like I said, that's my goal, is tomorrow morning, hopefully by lunchish, I'll have an announcement coming out in Canvas that says, here's how we're going to handle tests. Here's what kind of timeline I'm looking at to make that stuff happen. And certainly still giving you guys time to work on homeworks and ask questions and stuff like that before that stuff comes up, okay? Because I don't want to and the other thing is, I don't want to stack everything at the end, okay? The other thing is probably tomorrow, it'll be probably this weekend sometime, I'm going to get another video up about the project, okay? So that y'all understand what's being asked on the project, what's expected, how to get that back to me, timeline, all that kind of stuff. Because right now we're about a month-ish out from kind of end of the semester type of thing. And this is usually about the time I want to give it out, where I go, hey, we've discussed it, we've talked about it. Here's what I need you to do. And I try and give everybody about a month to get it done, okay? So that it's not one of those things that it's being crammed. Hey, by the way, here's 4 days to get this done. I don't want that to be the scenario. Like I said, I'll have an announcement coming out on Canvas tomorrow, hopefully by lunch, to let y'all know what's going on with that. And then also a video, hopefully before the end of the weekend, about the project, okay? So that's it. I realize this session was a little bit long, but it's kind of a beefy, it's some beefy stuff. Yeah, it's some beefy stuff. So that's it. Have a great rest of your weekend. Stay safe, stay healthy.
Thanks for everything.
Bye.